Dive into the enigmatic depths of the Mariana Trench, the deepest point on Earth. Discover the Challenger Deep, mysterious bioluminescent creatures, hydrothermal vents, and extreme pressure conditions. Explore the history of human exploration, volcanic activity, and the unique ecosystems that thrive in total darkness. This is a journey into one of Earth's final frontiers, filled with wonder, science, and the resilience of life in the most extreme conditions imaginable. Please subscribe my YouTube channel and press the bell icon for new update. The Mariana Trench, nestled in the western Pacific Ocean, is Earth's deepest known oceanic trench, lying to the east of the Mariana Islands and south of Japan. This crescent-shaped abyss stretches for about 2,550 kilometers, 1980 miles, in length and 69 kilometers, 43 miles, in width. It was formed by the subduction of the Pacific Plate beneath the smaller Mariana Plate, a geological process that has continued for millions of years, making the trench a site of immense tectonic activity. At its deepest point, the Challenger Deep, the trench plunges to an astonishing depth of approximately 10,994 meters, 36,070 feet. This depth is so extreme that if Mount Everest, the tallest mountain on Earth at 8,849 meters, 29,032 feet, were placed inside the trench, its peak would still remain submerged under more than 2 kilometers, 2 miles, of water. Such an environment is beyond the grasp of ordinary human experience, where light, warmth, and the familiar rules of surface life no longer apply. The life forms in the Mariana Trench are as extraordinary as the trench itself. In the pitch-black darkness, organisms have adapted in remarkable ways. Bioluminescence is a common feature, with species like anglerfish, lanternfish, and jellyfish using light to communicate, hunt, or defend themselves. Other unique creatures include the Mariana snailfish, which has been recorded at depths exceeding 8,000 meters. Its gelatinous body is specially adapted to withstand the crushing pressure of the deep sea. Crustaceans such as amphipods and isopods also thrive here, scavenging on organic matter that falls from the upper ocean layers, often referred to as marine snow. The trench's water temperature is as hostile as its pressure, averaging just above freezing, typically between 1 and 4 degrees 39 Gf. However, certain areas within the trench host hydrothermal vents, where seawater interacts with magma below the Earth's crust, emerging as superheated plumes that can exceed 300 dc 572 dF. These vents create oases of life in an otherwise barren expanse, supporting ecosystems driven by chemosynthesis. Here, bacteria convert chemicals such as hydrogen sulfide into energy, forming the foundation of a food web that sustains tube worms, shrimp, and other organisms. The pressure at the trench's depths is almost incomprehensible, reaching approximately 86 bars, 15,750 pounds per square inch, at the Challenger Deep. This is more than 1,000 times the atmospheric pressure at sea level, and equivalent to the weight of 50 jumbo jets pressing down on a single square meter. This intense pressure makes the trench one of the most extreme environments on Earth, one that can crush even advanced technology unless specially engineered to survive. Volcanic activity is another characteristic feature of the Mariana Trench. Underwater volcanoes and hydrothermal vents periodically erupt, releasing molten rock, gases, and minerals into the water. These eruptions not only shape the seafloor but also contribute to the nutrient cycles that sustain deep-sea life. Scientists have discovered sulfur and methane seeps, along with unique forms of microbial life, that may offer clues about the origins of life on Earth and the potential for life on other planets. Human exploration of the Mariana Trench has been a monumental achievement. The first daring descent into the Challenger Deep was made in 1960 by Jacques Piccard and U.S. Navy Lieutenant Don Walsh aboard the Bathyscaphe Trieste. Despite the limited technology of the time, they reached a depth of about 10,916 meters, 35,814 feet, briefly glimpsing the alien world below. More than 5 decades later, in 2012, filmmaker and explorer James Cameron made a historic solo dive into the Challenger Deep aboard the Deep-Sea Challenger. Cameron spent hours exploring and filming, returning with detailed images and samples that expanded our understanding of this remote realm. Only a few specialized submersibles have managed to reach such depth. These vehicles are meticulously designed to withstand the immense pressure with thick titanium hulls and advanced life support systems. Submarines like the Trieste, Deep-Sea Challenger, and more recent vehicles like the limiting factor have allowed humanity to venture into the trench's depths. However, manned exploration without a submarine is impossible due to the extreme conditions. Even robotic vehicles, such as remotely operated vehicles, ROVs, and autonomous underwater vehicles, AVS, must be reinforced to withstand the crushing forces at such depths. The Challenger Deep is not just a scientific frontier, but also a source of inspiration. It is a place where the boundaries of human knowledge are tested, where technology meets the raw power of nature. As scientists continue to explore the trench, they uncover new species, geological phenomena, and insights into the deep sea's role in global systems, such as carbon cycling and climate regulation. The Mariana Trench, with its alien-like creatures, crushing pressures, freezing temperatures, and hidden volcanic activity, remains one of Earth's last great mysteries. It reminds us of the vast, unexplored wonders of our planet and the relentless human spirit that seeks to uncover them.